Hello everybody, welcome back to Higher Learning Test Prep's online video tutorial series. Today we're going to be looking at a tricky one, number 59 here on the ACT. Supposedly a tricky one at least. The second to last question on the test. They're expecting almost no one to get this question right. The system of equations below has multiple solutions, all of which satisfy the equation y equals 4/3 x minus 2. If it can be determined, what is the value of a? Let's first of all just talk about this answer choice E. Always wrong on a hard question. It's never going to be so easy that you could just guess it. Cannot be determined from the given information. Typically not right at the end of a test. You might see an answer like this, cannot be determined, on number 10 and it could be right. But on number 59, it's never going to be right because they're not going to give us an answer that could be easily guessed if you had no idea what's going on. So that one's out. We know it's one of these four answer choices. I also noticed something here. If I was really close to guessing, I would probably guess -6, 9, or 18. Probably 9 or 18 because these numbers are all pretty related. And there's some sort of a pattern going on here. So I'd probably guess A, B, or D if I was randomly guessing. Let's not randomly guess. This is what I would call simultaneous equations. Two different equations that look very similar. And we're going to have to figure out some way of combining these equations. Sometimes we add them up. Sometimes we multiply. So we do all sorts of stuff. If we added these, we wouldn't really get anywhere. We would get 20x. We'd have two other terms. We'd have -6y and -ay. This isn't really going to help us. So my next idea is if I look at these, I see that these numbers are pretty related here. In fact, we have a common multiple of 6, 4, 12. All these numbers is 24 for this left side. So why don't I convert this to 24x? Okay, if it's 8x becomes 24x, we're multiplying this whole thing by 3. That would be 24x minus 18y equals 36. And then if we do, let's get this 2x or 12x down here to equal 24 as well. We'd be multiplying by 2. So that would be 24x. We'd also get times 2, -2ay. And then we get 18 times 2. What do you know? 36. Okay. Well, if these things are equal, 24x and 24x, 36 and 36 are equal. That means -18y and -2ay are equal. Even more specifically, -18 is equal to -2a. And now, of course, just some simple algebra divided by -2 on both sides. And of course, we would get a equals 9. Awesome. So there's our answer. Notice this was not necessary the way we did the question. Sure, you could use substitution and go about things in a much more laborious method. What they're hoping on number 59 is that you're smart enough to see that there's this relationship between our two x values and also our two answer choices. That essentially we can get these x's to both be 24x and these answer choices to both be 36 with some simple multiplication and then make our question actually fairly easy. Okay, so it's all about looking out for those relationships in simultaneous equations. Should I subtract them? Should I add them? Should I multiply? Should I divide? Hope that helps. Look for questions like this on your next ACT test when you're practicing. You'll notice with simultaneous equations, there's always a trick to make them more easy to work with. You should never have to do substitution. Hope that helps. Get in touch with us on Facebook, Twitter, email us, whatever you need to do. If you have a question, we will help you. We will help you solve your question on the ACT. Thanks. Take care for now.